Hello friends, welcome to our channel Bang on Theory. So friends, in today's video we are going to discuss most important ETL interview questions for ETL testers, ETL developer, and some data warehouse related questions as well, and also scenario based questions. So in this video we are not going to discuss all the topics in detail, but just to give you a quick overview for any of the upcoming interview of yours. So let's start. So before start, please watch this video till the end, support this series, subscribe our channel. Let's start. So the first question is differences between ETL and ELT. So if we talk about ETL, so we know extract, transform and load. So process order of ETL is extract, then transform, then load, and ELT first extract, then load, then transform. So if we talk about transformation location, so ETL performed on a separate processing server and ELT performed within the target system, example data warehouse. So in ETL data transform before loading, and in ELT loads raw data first then transform. So what is the use case of ETL? Smaller data sets, complex transformation and data security. And if we talk about ELT, then for large data sets and leveraging cloud data warehouses and real-time processing. So here are some examples: Informatica, Talent, Microsoft SSIS, and Google BigQuery, Amazon Redshift, and Snowflake. So if we summarize all of this, so ETL transform data before loading, ideal for ensuring data quality upfront. And if we talk about ELT, so it loads data first then transform. So it leverages the power of modern data warehouses for large scale data processing. So the next question is, what are the different most popular ETL tools? So we have discussed some tools. So the first one is Informatica Power Center. This is the most popular ETL tool. Next is Talent. Talent is open source ETL tool offering a wide range of data integration and transformation capability. And SSIS, it integrates with Microsoft SQL Server for data extraction, transformation and loading. And then we have some more tools as well: Apache Nifi, AWS Glue, Google Cloud, Evo Data, Azure Data Factory, one of the most popular ETL tool, and Azure Synapse. Okay, so the next question is, what are initial load and full load? So if we talk about initial load, so in initial load we load the data for the first time. If we are trying to load the data for the first time, so the data volume typically large as it includes all historical data in one go. Okay, and one time or infrequent. And if we talk about full load, so basically loading all data from source to target. So it can be large depending on the data set. And use case for initial load is setting up a new data warehouse and migrating any system. And if we talk about full load, so basically regular updates and data synchronization. So in terms of performance, it may take longer due to the volume of data, and full load optimized for regular intervals. So examples: initial setup of data warehouse, if you are planning to initial setup of a data warehouse, and in full load daily ETL jobs, day-to-day ETL jobs which are running to update data warehouse. And challenges what we face in initial load is handling large volumes and ensuring data integrity. And in full load is managing load items and ensuring consistency. If we summarize all of this, so in initial load, it basically used for the first time setup or migration and involves loading all historical data. And in full load, basically regularly uploads all the data from the source to the target, often used for periodic updates. So the next question is, what is the difference between OLAP and OLTP? So OLAP stands for online analytical processing and OLTP stands for online transactional processing. So as the name says, OLAP we basically use for analyzing the data, large volume of data for business intelligences and decision making. So we basically use OLAP for reporting purposes, BI purposes, and OLTP for transactional purposes. So it manages and processes day-to-day transactional data. And OLAP contains the data type historical data, aggregated and multi-dimensional data, and OLTP current real-time data, detailed and transactional data. And if we talk about schema, so in OLAP typically uses star or snowflake schema that we will discuss in the next slide. And if we talk about OLTP, it uses normalized schema to reduce redundancy. Operations: complex queries, data mining and reporting. And in OLTP, simpler queries: insert, update, delete operations. Complexity, high complexity in OLAP involve aggregation and joins, and in OLTP low complexity, focus on individual transactions. So OLAP optimized for read heavy operations and OLTP optimized for write heavy operations. And in terms of data volume, OLAP holds large volume of data, often in terabytes or petabytes for analysis, and OLTP smaller volumes of data but high transaction rates. And definitely it takes longer response time due to complex queries, and OLTP faster response time, typically in milliseconds. Use cases, as we discussed, OLAP used for business reporting, data analysis and financial forecasting, and OLTP for order processing, inventory management and customer transactions. Here are some of the examples. OLAP, data warehouses, marts like Amazon Redshift, Google BigQuery, and OLTP, operational databases, MySQL, PostgreSQL, Oracle database. So the next question is difference between BI tools and ETL tools. So if we talk about BI tools, so BI tools we use for analysis and for decision making purposes. And if we talk about functions, so data visualization, reporting, dashboard, and ETL basically for data extraction, transformation, cleaning and loading. Okay, so use cases, business analysis, performance tracking and strategic planning. And in ETL, data integration, data migration, data preparation for analysis. And examples are Power BI, Tableau, ClickSense, and for ETL, Informatica, Talent, SSIS. So if we summarize, so BI tool focuses on analyzing and visualizing data to generate insights and support decision making, and ETL tools focus on data extraction, transformation and loading process to prepare data for analysis. So the next question is, what are some common sources from which data is extracted in ETL? So these are the most common sources. So relational databases, MySQL, PostgreSQL, Oracle, SQL Server, NoSQL, MongoDB and Cassandra, flat file, CSV file, TSV files, and XML, JSON. So these are the sources from which data is extracted in ETL. So the next question is concept of a data warehouse. This is one of the most important interview question. And what is data warehouse, difference between data warehouse and data lake, that we will discuss. So if we talk about data warehouse, so it is a system, it is a central repository that aggregates data from different sources into a single central consistent data store, and to enable support business BI activities, especially analytics. Okay, so if we talk about data types, so it contains structured data and semi-structured data. And if we talk about unstructured data, that we will discuss in next slide. And components, these are the components: central database stores the data, ETL tools extract, transform, load, and metadata, access tools for querying and reporting. And if we talk about architecture, so we have top tier, middle tier and bottom tier. And benefits are, it is a centralized data repository that we have discussed, improved data quality and consistency, enhanced BI performance, and it supports historical data analysis. And these are all the benefits. If we talk about use cases, so it basically used for reporting analysis purposes, and data consolidation from multiple sources, aggregated data we have for analysis and analytics purpose, and historical data storage supporting decision making processes. And examples, we have different examples for different industry like healthcare, retail and finance. So the next question is data warehouse versus data lake. So data warehouse we have already discussed, and it contains structured and semi-structured data. And if we are talking about structured, semi-structured and unstructured data as well, that for that we have centralized repository called data lake. Okay, like ADLS Gen 2. So and so schema for data warehouse is schema on write. Schema is defined before data is written, and for data lake it is schema on read. That means schema is defined when data is read, and processing is ETL, data is transformed before loading. And for data lake it is ELT, data is loaded in raw form and transformed as needed. And in terms of storage costs, data warehouse is generally higher due to optimized storage for structured data, and data lake is generally lower due to inexpensive storage option for raw data. And performance of data warehouse is obviously high for complex query analytics, and for data lake scalable for large volumes but may require additional processing. And use cases we have already discussed: BI reporting, historical data warehouse, and data lake, also big data analytics, but machine learning, real-time data processing we can also perform. And examples are Redshift, Google BigQuery, Azure Synapse, and data lake S3, AWS Gen 2, Google Cloud Storage. Yeah. So the next question is difference between OLAP tools and ETL tools. So OLAP tools, online analytical processing, that we have discussed in previous slide, and ETL tools, and we have discussed. So OLAP is used for analysis purpose, and functions are multi-dimensional querying, data aggregation, complex analytical calculation, and ETL extraction, transformation, cleaning and loading. And it uses for BI intelligence, reporting and analysis purpose, and it uses for integration and transactional purpose. So here are some of the examples, and if we summarize this, OLAP is used for decision making, insights based, and ETL is used for extraction, transform and loading process to prepare data for analysis. Okay. So the next question is, this is one of the most important question: explain facts and dimension table. So if we talk about fact table, so it stores quantitative data like sales amount, quantity sold. And if we talk about dimension table, it contains descriptive data, descriptive attributes, provide context for the fact such as customer name, product category. Okay, so it contains measurable events and statistic values like transactions, and it contains descriptive information like categories. So if we talk about schema, so fact table typically contains foreign keys linking to dimension table and measures, and dimension table contains primary key that are referenced by fact tables. Granularity is high in fact table, capturing detailed transaction, and in dimension it is low. So examples are sales transaction, order details, financial metrics, and in dimension it is customer details, product information. And usage we have discussed, used for aggregating and analyzing data such as summing values or counting transaction, and in dimension used for filtering, grouping and labeling data in reports analysis. Okay, so the next question is, explain star schema and snowflake schema. So the star schema is a type of database schema where a single fact table references multiple dimension form like a star structure. Okay, and in snowflake schema, a more complex variation of the star schema where dimension table are normalization operation we perform into multiple related tables like a snowflake like structure. So in this we simple with denormalized dimension table directly connected to the fact table, and in this complex with normalized dimension table connected through multiple related tables. So if we talk about query performance, so faster query performance due to fewer joins, and in this there are multiple joins, so query performance is slow. And storage efficiency uses more storage due to data redundancy, and it is less storage efficient. And design complexity, simple design, easier to understand, and it is complex. So if we talk about use cases, so it is suitable for simpler data models and faster query performance, and it is for complex data models. An example, sales data analysis with direct links to product, customer and time dimension. And in this example, detailed customer data analysis with normalized tables for customer. If we summarize all of this, so in star schema offers simplicity and faster query performance with a single table for each dimension, so it make it deal more simpler data model and faster queries. And snowflake schema provides better data organization and storage efficiency by normalizing dimension tables, so it make it suitable for complex data model. So the next question is, what is data mart? So data mart is a focused subset of a data warehouse. So it is basically a subset of a data warehouse. So it is designed to serve the needs of specific business lines. So if we talk about example, in this example you can see we are talking about a retail company which has central data warehouse containing all its data. The marketing department needs quick access to data related to customer demographics like purchase history, campaign performance. Instead of querying the entire data warehouse, they have created the data mart called marketing data mart. So this data mart includes customer profiles, purchase transaction, campaign results. So they have created a subset of the major data warehouse. The purpose of this is tailored for a specific department or business unit. Okay, benefits are enhances efficiency, reduced cost, and provide faster access to critical insights. So the next question is, explain staging area in ETL. So staging area is basically a temporary storage location used during the ETL process. So to hold before performing any transformation, we are storing the data which we have extracted from the extracted layer, extraction layer, into a temporary staging area for cleaning purposes, to hold data extracted from source system before it is transformed, loaded into target system. So the purpose is simple: aggregate data from multiple sources and store it in staging area, perform data cleaning, data transformation, and performance optimization. And the key functions are: temporary storage, holds raw data temporarily; data validations, actions; data transformation; at the end, error handling. So the next question is, why data transformation is important? So the data transformation important is because to improve the quality of data and to integrate the data from different sources. And before loading the data in load layer, we transform the data cleaning, data aggregation, all different operations has been performed, so that when we load the data into final layer to target data, we can analyze the data and give the best business insights, and helpful for compliance and security, performance optimization. And these are all the important and benefits for data transformation. If we talk about use cases, so transform raw sales data into standardized format, like aggregating it by region, time period, and enriches it with demographic information. So the next question is, explain incremental data loading. So incremental data loading is main objective of this is, let's take an example. A retail company wants to update its data warehouse with daily sales transaction. Okay, so they don't want to put the whole data, the whole file. They want the just they want to upload the last updated data, okay, the latest data. So retail company wants to update the data warehouse with daily sales transaction from multiple stores without reloading the entire data set. So the steps are: first steps is identify changes. For that we must have that particular identifier column. So in this case, we have log transaction with a timestamp. So the ETL process identifies the new transaction by comparing timestamp with the last load, and then extract the changes as per this column, and extract only the sales record that have been added or updated since the last ETL run as per the timestamp, and use SQL queries, API calls to fetch those records from the ERP or from the source system, and then perform the transformation operations by removing duplicates and correction, and handle null values, and standardize the format as per the requirement, and at the end aggregated data using group by and having clause, and at the end load the data to the target database, and use techniques like upsert and SCD technique, whatever required. So the next question is, techniques of incremental data loading. So there are different techniques of data loading. First one is timestamp based loading, that we have discussed in last example. So as per the column, like timestamp column, we can identify the data as per the last load, and can only upload the latest data, the required data. Next we have chain data capture. So it tracks and captures changes, insert, update, delete in the source system. Okay, and for we have different types of CDC and SDC. And then we have chain tracking, delta loading, load only the difference delta between the current and previous data sets. So it basically compares the current data set with the previous snapshot to identify changes. Incremental file loading, that we have discussed, and slowly chain dimension, SCD. So for that we have different types, SCD0, SCD1, that we will discuss. So the next question is, 3-tier system of ETL and how does it function. So first one is staging layer. We have discussed ETL operation, but we are talking about 3-tier system. So that is also the same, but if we talk about staging layer, so staging layer basically temporarily we have discussed storing the data before pushing it to transformation layer. So act as a buffer to handle data inconsistencies and error before transformation. Activities like data extraction, initial validation, and storage. So if we talk about data integration, so basically transform data into consistent format suitable for analysis. So we perform data quality and consistency through cleaning, standardization, and enrichment. And at the end, access layer, load layer. So loads the transformed data into target system, typically a data warehouse. So purpose is to make available for querying and reporting and analysis purpose. And activities where we perform is data loading, indexing, partitioning to optimize the performance. So the next question is, characteristics of snapshot and what is their meaning. So these are the characteristics of snapshot in ETL. First one is point in time capture. So snapshots capture the state of the data at a specific moment of time. And then read only, read write, Okay, space efficiency, fast creation, versioning, temporary storage. So these are the characteristics of snapshot and ETL. So the next question is, how do you handle duplicate records during data loading? So these are the methods through which we can handle duplicate records during data loading. So first one is identify during extraction. If we can able to identify that duplicate records before extraction, so that we can do using distinct clause, or using select queries, optimize select queries, and through data quality tools to extract unique record. So data quality tools, so we can implement data quality tools that can identify and remove duplicates, aggregate functions like group by, count function, and deduplication in target systems, handle duplicate at the target system as well, monitor and optimize the pipeline. So set up monitoring and logging to detect and address duplicates promptly. So the next question is characteristics of snapshot and what is their meaning. So meaning and use cases in ETL with respect to snapshots are, first one is backup and recovery. So snapshots we can use to create backups that can quickly restore in case of data loss or corruption. During testing and development, also developer use snapshot to create stable environment for testing changes without affecting the production system. And data migration, so snapshot also facilitate data migration by capturing the current state before moving data to a new system. And system updates also, it allows for safe system updates by providing a rollback point. So the next question is, how do you test for data integrity during the ETL process? So these are the testing methods through which we can test the data integrity during the ETL process. First one is data validation. So basically just verify data matches between source and target, just compare it. And the solution we can perform, this activity we can perform by implement row counts and checksums, and also referential integrity checks, so we can ensure relationship between tables are maintained. And also validate primary and foreign key, uniqueness test, null value checks, data type and format validation, boundary testing. So these are all the testing methods through which we can perform data integrity during the ETL process. So what are the different types of data transformation? So these are the different transformation methods and type for data transformation. So first one is data cleaning. In this we perform different operations like removing or correcting errors, inconsistencies, missing values. Data aggregation, we aggregate the data which we are getting from different ERPs using group by, having clause. And data smoothing, removing noises from data to highlight patterns. And attribute construction, data normalization, logs transformation. So these are all the different transformation type we use in transformation layer. So the next question is, what is data cleaning? So these are the techniques to perform the data cleaning operation. So first one is removing duplicates that we have discussed, identify and eliminating duplicate records. So all the questions are interrelated, but interviewer can ask you question in a different way. So now interviewer is asking us, what is data cleaning? So the techniques are almost same. We are cleaning and optimizing the data before loading into load layer, but we should understand what are the techniques, what are the exact techniques in different layers. So in this we are removing duplicates, handling missing values, fixing structural errors, filtering outliers, data validation, and standardizing data, optimizing data, and removing irrelevant data, so that it can be helpful for business to gain the insights and to analyze the data. And the next one is challenges of ETL and big data scenario. So these are some challenges like data volume. So handle massive amount of data, can strain storage and processing resources. Data velocity, speed at which data is generated and needs to be processed, can lead to bottlenecks. Data variety, different varieties of data like structured, semi-structured, and structured. Handle this different category of data is very critical. And scalability, ensuring the ETL process can scale efficiently as data grows. And performance optimization, data quality, accuracy, consistency, and complexity, resource management. And most important is data security, protect sensitive data during extraction, transformation, load processes. And maintenance, also regularly updating and performing security patches, maintain ETL pipelines to adapt to changing data sources and formats. And the next question is, what is SCD, slowly changing dimension? So it is a concept in data warehouse that refers to manage of dimension data that changes slowly over time. So it is used to track historical data in a data warehouse and ensure data changes in dimension attributes are accurately captured and maintained. So these are different types of STD. SCD type 0, type 1, type 2, type 3, type 4. So in type 0, no changes are tracked, the dimension remains static. And basically use cases, historical data should never change, such as the product ID. And so on. Like type 1, overwrite old data with new data, no history is maintained. So use cases, correcting a spelling mistake in a customer name. And type 2 creates a new record for each chain, preserving historical data. Type 3 adds a new column to store the previous value. And type 4 uses a separate history table to track changes. So the next question is, how do you handle null or missing values during transformation? So guys, if you want part 2 of this video, please comment on this video, like this video, subscribe our channel, and please support this series. So we can handle null or missing values during transformation. So the methods are like default values. We can place default values, like replace null values with predefined default values like 0 or numeric fields, and perform imputation operations. So basically estimate and replace missing values based on a available data. And forward, backward, fill, interpolation. So these are different techniques. Like deletion, we can remove just delete the records with null values if they are not critical. And flagging, just flag the record, make records with missing value for further analysis. So add a flag or indicator column to identify records with missing value. Data transformation, we can add different transformation rules to handle null value during the transformation. We can implement different ML models, domain specific methods. So these are the different methods which we can apply to handle null or missing values. So the next question is, what are the some common issues found during ETL testing? So these are the most common issues, like data loss can happen during any of the operation like extraction, transformation, loading. So in any of the layer, data loss can happen. So solution is implement through data validation check at each stage. Data duplication, to duplicate record due to incorrect handling of unique constant, so we can use deduplication technique. And data inconsistency, so we can standardize the data formats and apply a consistent transformation rule. Missing or incomplete data, so validate source data at every layer. And performance issue, we can optimize queries. Data integrity issues, so we can enforce data integrity constraint. And we might face different issues with primary foreign keys. And unstable testing environment, so maintaining a stable and consistent testing environment is very important. And ambiguous requirement, so it is important to clarify requirement with stakeholders and documents and them clearly. And complex SQL queries, so simplify queries and use modular approach. And lack of proper test data, so it is very important to create comprehensive and representative test data sets. So the next question is, what is a lookup transformation? So lookup transformation is a process used in ETL to retrieve data from a referenced data set based on a specific lookup condition. So the key points are, so what is the usage of this lookup transformation is to add descriptive information to a data set, such as looking up customer names based on customer IDs. So basically it enhances data by retrieving related information from a reference data set. So it's commonly used in ETL process. So the next question is, how do you ensure data quality during ETL? So these are the different techniques which we can use to ensure data quality during ETL, like data profiling. So analyze data to understand its structure, content, and quality. Data validation, we can perform different data validation checks like data accuracy and consistency before and after. And data cleansing, that we have discussed, different data transformation rule, differential integrity, that these techniques we have already discussed. And we also have string pattern checks, freshness checks. Okay. Next we have, what are surrogate keys and why are they used in ETL? So it is a unique identifier for just like a auto increment key, so generated by system. So it has no real world meaning and solely for identify records uniquely. And benefits are consistency. Surrogates key are system generated and remain consistent even if the natural key change over time. Uniqueness, performance, and simplification, and at the end data integration. So it helps us to perform to identify the data, and these are the benefits. So the next question is, what is the difference between normalization and denormalization in data transformation? So normalization, we know to reduce data redundancy and improve data integrity, and denormalization is totally opposite, to improve data query performance by adding redundancy. So normalization we use to eliminate data redundancy and ensure data consistency. So it basically minimizes the data redundancy and enhances data integrity by reducing anomalies, and it may compromise data integrity due to redundancy. So storage cost, we can optimize storage cost by eliminating duplicate data, but it may require more storage space if we talk about denormalization. And query complexity may require more complex queries involving multiple jumps in normalization. So if we talk about use cases, so normalization use cases, it's suitable for transactional system where data integrity is crucial, and denormalization suitable for analytical system where query performance is critical. So the next question is, how do you transform unstructured data in ETL? So we can transform unstructured data using appropriate tool to extract data from these sources, and then perform some operations in pre-processing, like clean and pre-process text data by removing stop words, punctuation, and perform tokenization. And if we have multimedia data, then convert that data into analyzable formats using OCR and transcribing audio. And during transformation, we can use different NLP techniques and extract the features from multimedia data, like image recognition, audio feature extraction, and data structuring like tables or JSON. Okay, and at the end, loading layer, load the transform data into a data warehouse or data lake for further analysis. So the next question is, what is data partitioning and how is it used during the loading process? So data partitioning is a process of dividing a larger data set into smaller to improve the performance and scalability and fault tolerance in data processing. So these are different process during the loading process in ETL. We can use like improved query performance. So by organizing data into partitions based on specific criteria like date ranges, geographical regions, so queries can be executed more efficiently. Parallel processing and resource optimization, incremental loading that we have discussed, and fault tolerance. So in case of failure occurs, only the affected partition need to be reprocessed. So the next question is, explain the different types of ETL testing. So these are the different techniques and types to perform the ETL testing. So first one is new system testing. So validate the ETL process when a new system is implemented. So ensure data is correctly extracted from various sources, transformed and loaded into target. Migration testing, accurately transferred from old system to a new one if we are performing any migration activity. Change testing, whatever changes and updates we have performed in ETL layer, so it shouldn't impact the current ETL process, okay, and existing data or process. And report testing, validate the accuracy of reports generated from data warehouse. And data completeness testing, data accuracy testing, data integrity, checks for data consistency and integrity such as primary and foreign key. And performance testing, so it shouldn't impact the current system performance and can handle large volumes of data efficiently. And the important one is regression testing, ensure that new changes or update to the ETL process do not introduce new errors or affect existing functionality. So the next question is, what are some methods to optimize ETL performance? So these are the methods through which we can optimize the ETL performance, like tackle bottlenecks. So identify and address the heaviest part of the ETL process. So we can implement log matrices or log metrics like time and resource usage, and we can load data incrementally. We can implement data by incremental load, and we can partition large tables into smaller tables for performance and data management. Cut out extraneous data, cache the data. So store frequently accessed data in memory, use cache to speed up retrieval. Process in parallel, use efficient ETL tools, optimize SQL queries like indexing, query optimization techniques, and avoid complex join. And monitor and tune regularly, like set up performance reviews and tuning sessions, and ensure data quality. So thanks for watching. Keep supporting, subscribe our channel, support this series. Thank you friends.